We can't show ray tracing, unfortunately. We can't show view rows. You can open it. It's so simple. You can see it. Go and open environmental analysis. Number 4. Oh, I pressed yes this time. You press no. Okay, go ahead. What we want to do here, we want to run a sunlight average study, and sunlight average study tells you how many hours of sunlight you see during a period of time, right? To do a sunlight average study, you need the sun vectors. Go ahead and generate the sun path and generate these sun vectors. And by now you should know how to do that. If you don't know, just type whatever I typed there, like import, and it will show you that. And then connect them all together, and then we will talk about it. First, weather data. I just connect this. This is not the right file path. Let's go back to Chicago. We didn't use Washington, right? Let me use this one. Dallas, open. So it reads all the data. Then I have the location information, so I can connect the location, to my sun path, which is not here yet. So I connected the location data to location. It gives me the sun path, but I want to generate it for multiple hours. So for 24 hours, I connect it here. Sunlight average is a standard, which kind of an urban design, kind of more of an urban design standard than architecture. And still, it's in many areas is part of a code. For example, if you have a residential building, on one, like, it depends on where the code is, but like they say, if you have a residential building, for the bedrooms, it should have 2 hours of sunlight during the 21st of December, which means during 21st of December, you should see at least two hours of sun. So what this component does, what I did so far is I generated the sun vectors for 21st of December, month 12, right? And now I have all the sun vectors. When I have all the sun vectors, I need some buildings. Just go ahead and draw some building, and draw multiple buildings, like 3. But be careful about the size. Don't go crazy just because of the time. I mean, you can go crazy all week. So I just do 4 buildings, and then I draw ground 2 for 2 reasons, because usually the normal is not in the right direction. So I do a ground, and then I type planar surface here. I just delete this, and because we don't have time, I don't make the mistake that I usually make to show you. I mean, this is, I can't see the direction because of the color. Okay, this one is right. So now I have my test buildings, right? I have my test buildings, I have my vectors. I can calculate the sunlight hours, which means how many hours of sunlight I see for every surface. It's pretty simple. Let's run it first and then talk about it. So I just select everything that you did draw, whatever you have, right? And then right click on this BRAP and set multiple BRAPs. I already set the grid size to 4. Already the distance from base is 0.001. And why this thing is happening is, in many of the analysis, including daylight analysis or radiation analysis, you have to represent your geometry to the engine. And it doesn't understand the surface. So you generate some test points for that surface. I assume you have run multiple daylighting analysis, right? So not always, but one of the ways is you generate a grid test point. This component takes care of that by asking you the size of the grid and distance from point. If you don't click the sun, if you don't connect the sun vector, and set run it to true, it does something. This is one of the other like turbo buttons that is nowhere, but you should know. So there is an output for test points. If I type point and connect my outputs here, it shows me the test points. What's the use of this? It's so useful to check like how dense your grid is. So now if I change the size of my grid, you see it changes the size of the grid point. And because I don't have the sum vectors connected, it doesn't run anything. It just generates the points. So I make sure the point sizes are right. And for example, if you have this and your units are on millimeters, then 4 is going to be 4 millimeters. For you, that like 4 millimeters is so small. If you don't know what is 4 millimeters, if you're working with IP, it's something is off an inch. I don't know, 1/32 something. I don't know. So it's now I know my test points. I think they look good. This is the right size. So what I do, I just go ahead and connect my sum vectors. But you see here, parallel is set to true. The reason parallel is set to true is you want to use all the CPUs that you have. So this computer has 8. Is it 1, 2, 3, 4, 5, 6? No, of course it's more. I can't even count. So there should be a number somewhere that I can't find, but it has like more. And I want to use all the CPUs, so I just set the parallel to true. And now if I connect the sum vectors from here to sum vectors, done. So I got the sunlight average. And what happened here is for a second it went high and then it came down. And because the number of points is not that much, it just calculated it. So what it tells me is basically now the scale is not in the best place. I can go use the legend parameter to move the scale, but just for the sake of time, let's go ahead. So it changes between 0 hours to 9 hours, and you can see these points are seeing 9 hours. This one's doesn't, right? If you're doing a design, because it's pretty fast, you can just select your box and just move it from here to here. It will rerun the analysis, give you the new result. BRAP is basically all my test buildings. What BRAP stands for? BRAP is boundary representation. It's poly surface. How? How did I get the grid? The test points that I showed before, there is an output here, test points. But I set the visibility of the output to false by default. So if you want to see it, you can use a preview component, for example, or you can bring a point collector. And then you can connect these test points here. So it basically colors every single surface based on the result for this test point. So every test point represents a surface back there. And if you want to see your surfaces, press Ctrl M again. And this is the surfaces. So what happened is inside the component, based on this size, grid size, I mesh the geometries, generate the test points, run the analysis. So it basically takes care of all that stages. So you get this sunlight average. Now you can start doing some interesting stuff. Do you have any questions first? So now let's say we ran this and we said, okay, I don't want really to see this sunlight average values on all the geometries. I only want to see it on the ground. And all this stuff is going to be just like making shadows or shades, or whatever it is. You can see there is a context input here. So whatever you connect to geometry, you tell to the component that I want to run the analysis for this. Whatever you connect to the context, you tell the geometry, consider this thing as a shading. Don't run the analysis for this. So let me go ahead and do that. So I select this one, first of all, you turn off the run it to false, so this thing doesn't run the analysis every time that you connect it. I select this, I connect it here, right click, send one BWrap. So now my geometry, if I preview on, is only my ground. And then for the rest, I connect it here, I have a test geometry. Don't use this one because it will run the, oh, we don't have a point. I don't know, we have time. Okay, I just brought a BWrap and then I selected the rest of geometry and set multiple BWraps. So what will happen now is these BWraps are only shading over this. So I just set this thing to right, to run, and now you see there is no radiation on top of this buildings, but you can see the sunlight average values here. And does this sunlight average look familiar to you? Like what you see on the what you see on the ground? What do you call it in a normal way? Yes. And if you want to see it better, if I take the legend parameter here and color it between black and white, custom color, and then I connect the legend parameter. Oops. This is a shadow range study basically that you run, right? Because it's not like when you don't see the sun, basically you have a shadow. So you can use this to run shadow studies too. I mean, like we will see next week that you can run it with radiance and it will be like much better. But now I got this result. For example, we are running it for a landscape. We have this development, and we know in the areas that I can get more than 6 hours, I can basically have kind of plants, right? So I want to find the areas that I have more than 6 hours of sunlight average. I could do the same for the buildings and say, show me where my buildings get more than 2 hours so I can have my residential units. The same concept. How you do it is, this is what I said, you get so many outputs, but some of them are useful for each case. So here you have sunlight average result. If you connect a panel, so for each point, test point, you have one values. You see it tells 3,300, good number. So you have 3,300 faces here for your analysis mesh, and you should have 3,300 of test points, right? There is a component, so the output here is a mesh. The output is sunlight average is a real mesh. If you bake this, we didn't bake anything, but you can bake it actually. So if you want to keep this result for yourself inside your file, you can right click. I mean, if you right click, it will bake multiple things, but I do this. So I do a mesh. I just connect sunlight average here and I bake it. And now as soon as I bake it, this is a real mesh. This is a Rhino mesh. Which means when you have a Rhino mesh, now I can't see anything. It's colors because my view is set to wireframe. But as soon as I change it to shaded, I can see it. So you have the colors. This is a real mesh. And a real mesh means you can 3D print this. You know? And I will bring some 3D prints of Radiance Sky next week. As you can see, you can 3D print the sky. Because it's a real geometry. You can give it a thickness. You have a 3D printer here, right? You have Z-print? Color Z-print? Yeah, okay, so you can even 3D print your radiation analysis with SunPass and all that stuff. But now, how much does it cost to do that? Here, too much? Okay, don't do it. So I just turn the preview off here and I go back to the wireframe because it's easier to see the stuff. I don't want to hide the geometries in in the in Rhino. So this is the final thing that we want to see, and it's just like how to use the values to manipulate the geometry that I have. I want to find how much is the area that I can grow the plant that needs more than 6 hours of daylight, of sunlight during the 21st of December in this place. So I have the result, right? Sunlight average. And you should remember, how could I say that? I can say whenever it's more than 6 hours, or I can say whenever it's less than 6 hours. For now, it's just up to you. I want to remove the faces that are receiving less than 6 hours, because I want to have the rest of the faces to calculate the area and say to my developer, oh, this is amazing. We have this much of area, which is this percentage of the total area. And this is way better than the other option that we have, which is block the sun, for example. So I say wherever is more than 6, is smaller than 6. Then I connect all my values here. Now you should know what is the output of this component is false and true, right? True, false, true, false, true, false. So again, I had 3,300 points. I have 3,300 mesh faces. And based on this, I want to call my faces. There is a component for that in Grasshopper. It's called call faces. What it does, you can input a mesh, and then you can input a pattern. And based on a pattern, it will remove the faces. So where is the mesh? Here, sunlight average mesh. I just connect this here, and then I just connect this one here, and I preview off this guy so you can see. So these are the places that are receiving more than 6 hours. Oh, oops, not a good design. You get something here, right? And now this mesh, I can bake it again so you can see better. Can you see that? Okay, I'll show you how to do it again. So I remove that, delete this. Do you have this sunlight average output as a mesh, like this one? So you have the mesh, right? So you bring this component here, you say whenever it's smaller than 6. You don't have a mesh. So the output of this thing is empty. Did you set the analysis to run? So when you output this, it should give you a mesh, a join. So turn off the preview of this one off. So I go mesh, call, doesn't come, call faces. I connected the mesh here. I connect this one here. Now I have this mesh. I can use the area component to calculate the area. Then I can use the mass addition component to give me the area of this, sorry, the total area. Then I can divide it by the area of by the area of the base surface, base test surface, which is this surface, right? This is the base surface. So I can do area again here. And then if I divide this by this, 50% of the area, but good job, it's just all front of your buildings. But now, you know, like the simple logic, you can do it. Let me run it fast. So I set the run to true, to false. I just run it for the buildings now. Run. And I don't like these colors, remove this. You see, every time that I make a change, it reruns the analysis, but there is a component that's called recolor mesh that you can connect the outputs. We won't have time, but if you check the example files, you will see files, how you can use recolor mesh to change the mesh instead of running it over and over. So now I want to remove whatever is smaller than 2 hours. Seriously? So let's see, sunlight hours. Oh, okay, I made a mistake here. So what was the mistake here? For the first time, it was fine because I had only a single joint mesh and the pattern was basically in a single branch, right? But this time, I need to flatten this. So now it works. This is again the data matching that we talked about and you need to know. And you can see how easy it is to make a mistake. So watch your flattens like graphs. Like a good, usually say it's better never to flatten, but they say like in practice, theory and practice are the same. In practice it's not, something like that. So in theory and practice are the same. In practice is not. In practice it's not the same. In theory you don't want to flatten, but in practice you have to sometimes. So just go and learn what does it mean to flatten data, what does it mean to graph data and all that stuff. So now I have the area of my buildings that basically I can have a residential unit in this design. And the same goes here for radiation analysis. The difference between radiation analysis and sunlight average analysis is for radiation analysis you need some vectors. For radiation analysis you need a sky. If you instead of some vectors you input the sky, it calculates how much radiation you get. Make sense? Any questions? Comments? Do you want